talked about parallelograms in general. Now we're going to look at some special parallelograms, things that become special cases, just parallelograms with some extra things added on them. The first one's a rectangle. It's a parallelogram with all four congruent angles. All four angles must be 90 degrees. And the thing that we're going to find out, diagonals bisect each other. Well, we've known that already. Diagonals bisect each other because that's what happens in a parallelogram to begin with. So that's nothing new. However, we also know in a rectangle, diagonals will be congruent. So all four little pieces are equal because the big long diagonals are all the exact same length. So to look at an example problem and how we would do this, all we would look at here, if this is a rectangle, well, first let's look and say, well, if AB is 70, the side directly across from it is 70. AC is 50, the side across from it is 50. So that means BD here is 50, and we knew AB was 70, that means CD was 70 as well. And as for the middle segments, if I know that BC is 80, this big long thing is 80, that means each little one is 40. And if those two are 40, these two must also be 40. So all four of these answers will be 40 because they're all congruent. After rectangle, the other option, instead of all the angles being congruent, let's say all these sides are congruent. So again, because the diagonals bisect each other, we have a parallelogram. Now, the other thing that's kind of cool, because a rhombus is also a kite, like we said, diagonals in a kite intersect at right angles. Well, a rhombus is also a special kite, so diagonals here will also intersect at a right angle. Okay, so how we use this when we're solving these problems, first I'm going to look at, well, I have two sides here, so 4x plus 7, and the other side, 9x minus 11, their sides of a rhombus, they must all be the same. So I'm just going to solve it, making it 18 when I add 11, and making it 13x, or I'm sorry, not 13x, it would be subtracting, so 5x, and that means 18 over 5 will be my value for x. And if I wanted to turn that into a decimal, that'd be 3.6. And as for this angle, they're looking at this angle right here in the middle. Well, diagonals in a rhombus are right angles. They intersect at right angles. So that means 14y plus 20 is a right angle. It's equal to 90. I'll subtract 20 and get 14y equals 70, which means y will equal 5 for this problem. And then the last kind of special polynomial, or special parallelogram, is the square. And the square pretty much has everything. It's a special rhombus. It's a special rectangle. It has congruent sides and the congruent angles. So same thing, diagonals are going to bisect each other, just like we've done before because it's a parallelogram. Diagonals are perpendicular. We've done that from the rhombus. It's a special rhombus. And diagonals are congruent. That comes from being a rectangle. And just so you remember, a square is a special rhombus, and it is a special rectangle. But a rectangle is not a square, or a rhombus is not a square. It doesn't work backwards. So how we're going to do these, prove it's a square, we're going to just go right down the line and do, we need to know everything being true. So we'll start with saying that, well, if I want to know diagonals being congruent, my diagonals are AC and BD, made our little mountains over there as we call it. So we're going to have AC as our first diagonal. AC is going to be equal to, this is the square root to do it, I need to subtract the x's, 2 minus negative 1, and square it, plus subtract the y, 7 minus 0, and square it. 2 minus negative 1 is 3, so squared becomes 9, and 7 squared is 49, so 9 plus 49 is the square root of 58. I want to do the same thing for BD, and I should get the same numbers as a result. Subtract my x's, 4 minus negative 3 squared, plus 2 minus 5 squared. When I do that, notice the numbers I got before. I had 3 and 7. Notice what I'll get here, 7 and 3. So when I square them, I should get the exact same thing of 58 as my answer. Alright, let's look at the diagonals. We want to do the same thing. Diagonals being perpendicular this time, so I'm going to take a slope. And I want to get not the same slope, but opposite reciprocals. So for AC, subtract the y's on the top, subtract the x's on the bottom, 2 minus negative 1. So I get 7 over 3 as that first slope. For BD, subtract the y's up top, subtract the x's in the bottom. If I did 5 minus 2, I need to do negative 3 minus 4. So I'll get 3 over negative 7. That's the same as negative 3/7. So I have an opposite sign and a reciprocal, so I'm good there. As for bisecting, to bisect, that means that this point here in the middle where they intersect should be the midpoint of both diagonals. So I want to find the midpoint of each, the midpoint of AC, and I want to find the midpoint of BD, midpoint of each. So to do that, this is finding the average. So I'm going to add up my x values of A and C and divide by 2. So my x's are 2 plus negative 1 and divide by 2. My y's are 7 and 0, dividing by 2. That means my midpoint here will be 1/2, and this will be 7 over 2. And I'm just going to leave them as that, because it doesn't matter what they are, because I should get the same thing over here when I do that, for BD. When I do that, 4 plus negative 3 divided by 2, and then this one is 2 plus 5 divided by 2. And again, I get 1 over 2 and 7 over 2. So really you're doing 3 different formulas here. You're going from a distance formula to find the length, then we're going to do slope formula to check for perpendicular, and then we're going to end up doing the midpoint formula when I finish it up to do the diagonals bisecting. There you have it. Everything for doing these special parallelograms.